Good evening, everyone. Am I audible?
Yes,
Okay, so today we'll be having the second talk in our Astronomical Paradoxes series. So today's talk will be on the topic Fermi Paradox. And today we have our speaker Swastik Shinde from BSMS 2018 for the talk. And over to you, Swastik.
Thanks, Amisha. So I won't be switching on my video because of some internet issues. So I'll share my screen. Let me know if you can see it or not. Okay, so you guys, can you see my screen?
yes,
Yes. So yeah, all of us have heard the stories of aliens since long time. I mean, like since we have been able to read or listen to other people, understand what people are saying. Alien stories have gone. We have heard about aliens and alien stories. It might be Bermuda Triangle or it might be UFOs. It might be something else, but they have been there, right? But then, uh, like, how do these alien stories came? Like, how do these stories of aliens came? Why did these stories generated? And then, well, this question has been asked since long time. Okay, so like we are gonna this question, the question of where is the alien life? Where are the aliens? Like we have this huge universe, but where are all the aliens? That question has been asked since long time. And then like to answer it, a guy called Fermi told the Fermi paradox. So that was just the introduction or abstract. So we are gonna go a bit deeper, and it's not gonna be like the class lectures or the lectures you have. I mean, I'm not no offense to anyone, but it's not gonna be a bit. It's not gonna be boring. We'll have fun through all this. We'll have hear some stories and all. Okay. So first of all, how the concept of aliens came about. Okay, so before that, human, okay, is a really curious species. Like since the species of humans is born, we have been wondering about like stuff happening around. Like we like the how like the fire, how we discovered the fire, how we discovered farming, right? How we evolved from killing animals, living in a cave, to building homes, burning the woods to create fire, then burning the flesh or uh, the flesh we receive from killing something, uh, burning the flesh and then eating that burned flesh, and farming using the land to cultivate different plants and then eating the fruits or the vegetables. So that evolution, then other stuff like after that we started wondering about uh, the nature, like the things happening around, like the rain, like we started naming these stuff like uh, the things we don't understand by using gods, right? So for water we gave a god, then for fire we decided that fire is a god, then we decided that all the air is the god. Like we started thinking about this, like how these things happen, right? And then came the science. So this curiosity uh, led us to science. Right? Like we started wondering. We have been wondering about nature since we were born, right? The human species were born, and that led towards the birth of science. And after that, the astronomy. So looking, the stars have been there since the birth of the species, right? They haven't have like it's not like the stars appeared out of nowhere. They have been there since we were born, and humans have been wondering what are these stars out there, right? So there have been different concepts, like let's say the Galileos, sorry, not the Galileos. the Copernicus's imagination of how the universe is, Aristotle's imagination of how the universe is, what the stars are. Right? So these concepts have been there since a long time, and they have kept on evolving. And the food for this evolution had been the curiosity of humans, right? But then we didn't stop after the subject astronomy was born. Then we started wondering, like after uh, after the Hubble's after Hubble discovered the universe is expanding, and after the Big Bang theories, we found out how old the universe is, how big universe is. Then the question came in mind: in this huge universe, like there are lots and lots of stars, right? Like if we just see without any telescope, then itself we see thousands of stars, and there are more than that, like millions or billions of them, which aren't visible to our eyes because they are either very dim or they emit in some other wavelength, or they are very very far away. The light so that their light doesn't reach us. So overall, we have a huge amount of stars, and that's just in our Milky Way galaxy. Right. So there are other galaxies too where there might be stars, right? Where there are stars, not might be. Okay, there are stars. But then, if there are so many stars, why is is there a possibility that somewhere else life there would be any life somewhere else if there are some species which are as intelligent as us or more intelligent than us? That question started wandering about in the mind of humans, and that led to the birth of the aliens, the concept of aliens. So, in you might have heard about this in 1974. We sent a message. Okay, the so-called Arecibo message. Okay, in 1974, it was sent to the globular star cluster M13. Okay, so it's some 24,000. I'm not sure about the exact number, but about some 24,000 light years away from us. So it was sent to the Arecibo, uh, it was sent to the globular star cluster to demonstrate human technological advancements. But then it wasn't really an attempt to enter into a conversation with the species, but just telling others, if there is someone out there, they're telling them that how we have how advanced species we are, like how uh, like what are the technological achievements we have, what are the technological achievements we have made. So it wasn't exactly, as I said, it wasn't exactly a attempt to enter into conversation. So that time that this message was a part of a test of the update in the Arecibo telescope. So they had, and it was that of that time, it was the strongest radio signal uh, sent into the interstellar medium. Okay, so like that with and with the help of the largest Arecibo telescope, and I'll say RIP after that because, as we all know, the Arecibo telescope got destroyed last year. Okay, so the size of about 106 meters of the telescope it helped to reach the this to send us this strong message, which could if which could reach the this star cluster M13, and if there is someone living there, some other species living there, and if hopefully if they have a radio telescope as big as ours, then they can receive it and they will see how we have achieved. So this is the image of the Arecibo telescope before it got destroyed, and here you can see the message. Okay, so it contained like some of the numbers, then the basic elements of life, and then some of the basic chemistry of life, so chemical formulas, and then the chemical the chemicals and their formulas which are required for life, the nucleotides. Then there was the shape of DNA, the helix, and then also the that time known number of nucleotide pairs in humans. Okay, so that time it was thought that there are about 4.3 billion number of nucleotides, 4.3 billion nucleus in a pair of humans, in pairs of humans. But then later it's been found that the number is about 3.2 billion. Then there was the average size and shape of human here. So and then the that time world population where we live, so the location of birth, and then finally the size of the Arecibo Observatory's transmitter from where the message was sent. Okay, so this was an encrypted radio message. Okay, so this is how it would look if you convert it into a picture kind of image. But this was an encrypted radio message. So after the Arecibo message, the Voyager Golden Record of 1977 was sent. So before Voyager, the Pioneer 10 and 11 had they carried records of time and manufacture of them. So where at what time they were manufactured and where they were manufactured. So the Voyager Golden Record was a kind of like another step forward of the or I'll say another step ahead of the pioneers message. So the Voyager Golden Record contained a 12-inch gold-plated disc. So it was a gold-plated copper disc, and it contained sounds. So it had uh, the greetings in various languages. It had some classical music, like the Western and Eastern classical music. There were some other sound. There were some other musicals and sounds, etc. There, and then it contained images which portray like all of this was there just to portray the diversity of life and culture which is there on Earth. So, and both the Voyagers, Voyager 1 and Voyager 2, contained one disk. So the disk looks something like this. Okay, so you can see the different these notions which are there on the disk. And then after that, came the birth of SETI Institute. So all of you might have heard like recently we have sent like, there were we have sent a lot I have sent a lot of mails regarding the CAMS network, and from there you might have heard about the SETI Institute. So SETI, which stands for Search for Extraterrestrial Intelligence. So it was earlier uh, a part of NASA. Okay, a small project of NASA was funded to the project of search for extraterrestrial intelligence. But then two NASA scientists, George Billingham and Barney Oliver, what they thought is that uh, the funding required for this kind of project would be more. Okay, and then being a part of the NASA and being a small project of NASA, they thought that this uh, process might be a bit it would be a bit easier if this whole process was huge uh, a huge organization. Okay, and then they decided to with some other people there were Frank Drake was one of the people who was on the board of the first board of SETI, and some other people. So they decided to uh, start a non-profit organization which is there for just this purpose, just there for just discovering the life forms in the universe. So that's how the SETI Institute was formed. And then, since formation, the SETI Institute has been trying to look for life, look for life out there. So you might have heard about the Allen array of the SETI Institute. So like here in the background, you can see an image of it. So other like there are lots of projects by SETI which are there to look for the life out there. Then then later about a few years ago, Stephen Hawking and another Russian billionaire they came together to start a concept called as breakthrough message. So what they did to that, they invited people to consider how to write an alien message and send it. So and message to the aliens and to send it. And so that was the purpose of the breakthrough message. And then there was a prize of I think $1 million for that. So like, but they had decided for the moment they will not be sending the message. So these were few of the like points on the the concept like on the how we have been trying to find aliens. But then these messages and all these things, these sending messages and the golden records, etc., to out there also like kind of freaked out people. I mean, like some people started saying that maybe what will happen is that maybe aliens that they will come here and they'll try to uh, colonize her, they'll kill us or they'll attack us. Like, these kind of concepts these kind of imaginations started building, and that led to kind of more that led to increased amount of alien in kind of like I'll say people saying that I saw a UFO and all. Okay, so like the like, some of those concepts were the alien area 51. Okay, so the area 51 concept has been there since a long time. Like area 51 is there since I think like, that area 51 is an US Air Force facility which is there since I think World War II. Okay, so the area 51 has been named that because on the map of the US armies, it's been mentioned as Area 51. So from there, the Area 51 name came, and then so what people used to think is that like in Area 51, American scientists are doing some research on aliens, or they have found an UFO, and then these claims increased since after in late 1980s, a man who had earlier worked in there in Area 51, he started claiming that he was a part of a project where they were examining a UFO which was recovered. Okay, so but then uh, after that, then the pilots of the thing of the stories of pilots saying that they saw they saw an alien or any UFO while they're flying. So generally, these these were some other stories. Then the story of Bermuda Triangle or Easter Islands, the building of pyramids, all stories have been there. Okay, and these are not the only stories. Okay, there are a lot of many more, lots of stories there. But then, what's the truth? Okay, so first, Area 51. Area 51 is a highly classified US Air Force facility, right? As I told earlier. And there, during the World War II time, the development of U-2 high altitude aircraft was being done. And it, so the and this after that the stealth aircraft, like which you will not be able to see on radars. Those two aircraft has been those two the developments of those two aircraft has been done on the that region or in that area in that Air Force facility. So the thing is that the U-2 high altitude aircrafts not were not like the normal fighter planes. Okay, so they were faster. They used to fly higher, and they were they looked different than the normal aircraft which were there in that period of time. And because of that, the the people it's the report, and this is all based on the reports, okay, which has been put out by the area US Air Force. So so because of those spotting of those U-2 aircrafts was thought to be as the UFOs. Then the pilots, so all the claims of pilots were searched, and every most of the searches led to that the air balloons or radio sondes which the atmospheric scientists had sent up, so they reflected light, and that reflected light was observed by the pilots, and they thought that it's an air balloon. Then the Bermuda Triangle story was that it was it, people used to say that uh, people used to say that in Bermuda Triangle there are aliens which sink our planes and ships and all. Okay, so there is another story which you can read in Percy Jackson, the story of Scala and Charybdis. So as much as I'd want that to be true, it's not true. Right? Again, the Easter Island story. If you might have seen the Transformers, then the Easter Islands has been connected to the Transformers. Okay, and it's also a lot of people think that the pyramids were built by aliens. Okay, so all these stories led to nowhere. Okay, so there is no proof that these stories are true. We don't have any evidence that aliens are there. Okay, so we have tried, like, we have sent a lot of messages. We have been looking for last what 20, 30, 20 years, about 20, 30, or 40 else years, right? But we don't have any reply, or we don't have any evidence. So the question comes, where are all the aliens? Right? And that led to the birth of Fermi Paradox. So what Fermi Paradox says is that it is a contradiction between the lack of evidence for extraterrestrial life and various estimates for their probability of existence. So there are a lot of estimates based on the number of stars, the number of planets that should be there, and number of planets which are there in the habitable zones and all. So there are lots of estimates that there should be uh, just 1 second. Sorry for that. Yes. Yeah. So as I was saying, there are a lot of estimates saying that there should be ET. The ET should exist out there, but we don't have any evidence. The contradiction between these two is the Fermi paradox. So it was named after the guy who stated the paradox, who is Enrico Fermi. But he wasn't the first person to state this. So before that, Konstantin uh, Tsiolkovsky in 1933 stated the now known zoo paradox. Okay, so it was in an unpublished manuscript. So he said that people deny the presence of intelligent beings on the planets of the universe because first point was that if such beings existed, then they would have visited Earth. That is first point. The second point was that if such civilization existed, then they would have given some signs of their existence. So it kind of it kind of is similar to what Fermi said, but then just that he didn't publish it. Okay, so other than Constantine Tsiolkovsky, there are other people too stated who have stated the same thing. Okay, so 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 then the question is, what does Fermi paradox say? Okay, so we have found out that there are billions of stars in the Milky Way galaxy. So probability of having Earth-like planets in the habitable zone of the stars is high. Okay, so the question, what is habitable zone? So habitable zone is the region around any star in which water can exist in liquid form. Okay, so if you go a bit closer to the sun, then or the star, the water will evaporate. If you go a bit far away, then the water will freeze. So it's just that part of the orbit where or the that region around the star where the water is in liquid form. That region is called as habitability zone. So based on the recent observations, which the NASA's TESS uh, TESS telescope and the Hubble telescopes have been doing to spot the exoplanets. So based on that, there is a huge, like, based on the number of planets found and number of planets in habitability zone, there is a huge probability that there might be Earth-like planets in the habitability zone. So if that's the case, then many stars, there are many stars which are older than the sun. That means their planets also are of the similar age. If you compare our solar system to other solar system, because in our solar system, the age of our sun and age of age of the Earth is nearly same with a few million years of difference. The same would happen on the other solar systems too. And if that's the case, then uh, then some of these planets, some of these habitable older planets, might have developed intelligent life long ago. Okay, and then they might have uh, they might have gone through technological advancements. They might have built uh, telescopes, these huge telescopes. They might have built. They might have reached space, such space travel, so that they can travel through interstellar space. They can travel through solar system. They can travel through the galaxies. They can travel at light speeds. They might have achieved all these technological advancements. So, like, if we consider the number, okay, and if we try to calculate the number, so there are some equations which you can use for that. And if you try to calculate this number, then it is it's not a very small number. Okay, it is considerably a high number. But then, if that's the case, then Earth should have been visited by now. But it's not. I mean, we don't see any evidence for that. I mean, we don't see any evidence on Earth that we have been visited by alien life. We don't see any evidence in the Milky Way that there are some alien life. Like, we haven't received any signals showing that there is any life or something like that. So if in that case, well, that leads to the Fermi paradox. So that gives the birth to the Fermi paradox. So then comes the Drake equation. Okay, so the Drake equation is something that tries to calculate. I won't say that does calculate. Okay? I won't say that it calculates precisely, but I'll say it tries to calculate the number of advanced life forms which should be there. Okay, so it wasn't been it wasn't he didn't write the equation. He didn't write the equation to to kind of for this purpose, to calculate the number of the life forms. Okay, that was done later. The calculations were done later. But in 1961, when Frank Drake wrote the equation, it was as a way to stimulate dialogue at the first scientific meeting on the search for extraterrestrial intelligence, which was held in 1961. So it was a part of the first scientific meeting on the search for ET, and not an actual equation to calculate the number. The calculations were done later. So what does Drake equation say? So the Drake equation is um, it it's it tries to estimate the potential number of intelligent alien civilizations in our galaxy. Okay, so you can see the equation over here. Well, according to some, it's the second most famous equation after the Einstein's E equal to mc square equation, according to some. And well, like now, how it works. So the R star, this first number, is the average rate of star formation. So the number of stars which form every year in our galaxy. And then the second term, Fp, is the fraction of those stars that have planets around them. And then the third is the average number of planets in uh, those solar systems, in that solar system that can support life. So if I let's say that I have one solar, let's say that I have uh, 15 solar systems in our galaxy. Okay, then out of those 15 solar systems, what is the average number of if I calculate the number of planets which are habitable and terrestrial, so which are rocky and lie in the habitability zone, and then I divide it by 15. In that number, or the number of the number of solar systems, if I divide, if I calculate the average number of the planets there, so that's the second term, any. The third term is the fraction of planets that actually develop life. Okay, so life cannot be developed on every planet. So every planet that can support life will not lead to development of life. Okay, the reasons we'll discuss a bit later why that is the case. And then the Fi is the fraction of planets that where the life actually goes on to develop intelligent life. Okay, so developing a life form and developing an intelligent life form are two different things. Okay, so in like for Earth, in the case of Earth, the first life form was just one single cell, okay, one single primitive cell that after a few millions, after a few thousands or millions of years, that life form, that single cell, evolved into what we are now, into the humans, the intelligent life of humans. Okay, so these two are different things. It's it's not the case that every time the primitive cell is generated, it will it will evolve into an intelligent life. No, that won't happen because there are lots of parameters there are which can cause the destruction of that life forms, of the life forms, even before they reach to the intelligent life phase. Then the next term is FC, which is the fraction of intelligent life that release directives, that release this signs, or that release the EM radiation into the space, telling that they are there. Okay, so that's the next. So like not every, not every it's it's possible that not every life form will release these signs or signals. Some might be some might don't want to be detected, right? So that's the this FC term. Then the L is the expected lifetime of the civilization, okay, for the period that it can communicate across the space. So it means that for how long this life form exists. So like let's say that this life form came around in year one, and then it got extinct in year 10. So in 10 years, well, we won't have any uh, well, developments, right? Or let's say, and even if it lasted for a few millions of years, then it might be possible that those millions of years are not enough for them to communicate. Or maybe they communicated, maybe we received the message, but by the time we received the message, they have gone extinct. That is also possible. So then that number for how long this civilization will exist, that number is the L, and that leads to the number N, the number of civilizations in our galaxy, with which communications might be possible. But now we have the equation, okay. But then there were lots of estimates for these numbers, like for all these terms, okay. There were lots of estimates for what these terms would be, and there were lots of estimates for what N will be, okay. And every time we found out that N is non-zero, it's more than zero. But then, well, we can't say that this is totally right, this is totally true, because the fact is that we only know the first term to be true. Okay, so like we only know what is the first term, what is the average rate of star formation in the galaxy. That that is the only term that we know, and which is about 1,000 stars, 1,000 solar masses per year. That's the only term we know. The second term we know, I'll say we don't know it to be at the full, at, at its fullest. So we have we know some estimates of it. Same is for the third and fourth term. sorry, same is for the third term, and a fourth term for some extent. So these are the only four terms that we know at some extent. But the remaining three terms, well, we are not sure what these values could be. So the Drake equation was put forth in 1961, and after the break, after that, about what 60 years have passed. But in the 60 years, the only exact value which we know is the first term. Okay, so well, now you see the problem in the Drake equation and in the estimation of these intelligence aliens civilizations. Okay, and then here, so that I want to note here the first this term. Okay, so if we exclude L, then the first six terms together are called as the freshman rate. Okay, so the freshman rate is the average number of new technologically advanced societies that come online every year in Milky Way. So, like the average, if we say that, if we consider it as, let's say that it's a human, let's say that I am the freshman, right? Okay, and now you are looking at, and now I'm using my WhatsApp account. Okay, so whenever I open the person who is online on the other side, which is humans, they will see that I'm online. Okay, so me being so I am one of these alien species. Okay, and I came online. So how many other species like me will come online? That's the freshman rate. And the second and the last term L is for how long I stay online, or for how long these alien species which came online will stay online. Okay, so sometimes I'll stay online for just 1 minute. Some might stay online for an hour. Because I'm talking about online being WhatsApp, online being on WhatsApp. Okay, so I'm just comparing WhatsApp to be this universe. Okay, so if I stay online for a minute, some other species might stay online for an hour. Every species is online for that is based on don't know. So the paradox still stays.
Swastik, hello, hello. Your voice is breaking.
Oh shoot, is it better now?
Yeah, it's fine.
Yeah, yeah. So sorry for that. So yeah, so the Fermi paradox talks about that only. This only. So we have say the equation is not the only estimate. Only it is not the only estimate we have been put for aliens. There are lots of other such estimates or estimates there which say that alien life should be there, but we don't see any evidence. That's even paradox. So after the Fermi paradox put forth, now what people did was they tried to put forth hypotheses for the lack of evidence. So the thing is that humans, well, we can't. Uh, if we say that something is not going right, something is going wrong, we will try to put reasoning that why it is not going right. Yes, so that's how we are. So that's how each and every one of us is are. Like I'm talking about you. I'm talking about just human. I'm not saying about like me or you or someone else. Talking about the huge whole human species. And that's how we are. So so after the Fermi paradox was put forth, everyone tried to put forth hypotheses for the lack of evidence. And then the next part was a bit funny. Okay, so some people were on point. Okay, while some people were like they put forth evidence, which seem to be straight from a sci-fi movie, which seem to be directly taken from a sci-fi movie. Okay, so one of them was a rarity of intelligent life. Okay, so like as I mentioned earlier, so this rate here, uh, Fi. Okay, so the term that it's there, that itself that itself explains that not every planet will go on to develop life, right? So that leads to the this point, the rarity of intelligent life. So the fact that life is here on Earth, there are a lot of factors which play. Okay, so such that the size of the right size of moon, the presence of water, and the evolutionary phases that happened, and then uh, one of these was the deep Earth cycle. It's like the amount of carbon dioxide which is there. If the carbon dioxide wasn't there on the in the atmosphere, then well, we would not have been existed, because it would have been ice age here, because without carbon dioxide and without the greenhouse gases, the temperature would have been uh, about 255 kelvins, which is negative 30s something. And then we have to thank for we have to be thankful for the volcanoes and the deep earth cycle for the emission of carbon dioxide in the atmosphere. So these are some of the factors which help the life form which was there on Earth to evolve into intelligent life. And then there is the another factor, which is extinction by natural event. So in the last, since the formation of first life form, we have seen five major extinctions. The latest one was the extinction of dinosaurs by the so-called by uh, the, the asteroid which hit us. Okay, so like this, the life which is there, which might be intelligent, which might not be intelligent, can go extinct by any natural event. It can be because of some volcanoes have erupted, or some ice age, or it might be there's some ice age uh, which is there because the sun passed through a cloud. The solar system is passing through a cloud, and then there's a possibility that asteroids hitting them. The asteroids hitting it. There are lots of possibilities which might uh, cause the extinction of and the extinction of the intelligent life. And that leads to the first point, which is the rarity of intelligent life. The second hypothesis was that there might be intelligent life out there, but they are bit behind us. They have not developed advanced technologies. So that was the second hypothesis. Third one was that the nature of intelligent life to destroy itself or others. So since we have our intelligent life, we humans have been here for just some thousand years, and in those thousands years, we have seen a lots of wars, right? So there have been the major ones being World War I, World War II, then the Sikandar attacking the Indian subcontinent. So these are just some of them, pointing some of them. Okay, but there have been lots and lots of wars, and that leads to this third point, that the intelligent life tends to destroy itself or others. Okay, so uh, like uh, uh, there was a time during the Cold War that Russia and America was building up lots and they were building a lots and lots amount of these atomic bombs and hydrogen bombs, etc. So yeah, so the world was themselves, they depict this fact that it's the nature of intelligent life to destroy itself. Like we also have seen how we have destroyed the climates, right? Like with the use of carbon dioxides and with emitting CO2s and giving rise to the global warming and these harmful gases which are being emitted from the cars and factories and all. They themselves are some kind of poison for us. Okay, so like something, let's say a slow poison, maybe. Yeah, and then the second point is that they might destroy others too. So if let's say that if there is some other intelligent life, then it's this point depicts that is the nature of intelligent life, that it will destroy the other life form which is present there. Okay, so like let's say that we have been talking about going to Mars and colonizing there on the Mars itself, or colonizing on Moon. Okay, so let's say that it's just a hypothesis that if Mars had life, then to save ourselves from dying, to save ourselves from dying here, or due to some to save to decrease the population of on Earth and to save the Earth, we might the hypothesis says that we might destroy it. If there was some life form on Mars, then we would have gone there to stay, and if they hadn't let us in, then we would have killed it. That's what this third hypothesis says. So again, it's just a hypothesis. We don't know if that will happen because we haven't been there. Then the fourth is that the willingness of the life form to transmit. So maybe there are intelligent life out there which is listening to us. Okay, but it's not willing to transmit back to us. That's not a possibility. Like they want to be isolated. They want to focus on their own issues, and don't want to focus on if someone is out there or not. They are not interested. Like maybe it's the fact that we are interested. It doesn't mean that those are interested, right? So that's what this fourth point suggests. And the fifth point is that lack of resources. So there is an intelligent life. There is an intelligent life there, but they don't have as much resources as we have to develop these advanced technologies. Because of that, they haven't tried to contact us because of this lack of resources. That's another hypothesis. And then another one is that we haven't been listening properly, or we haven't been listening long enough. So maybe that these life forms these life forms emit in some other bandwidth. Like, they use some other ways to contact, and we don't know about those ways, or we know but we think that those ways we think that communicating in those ways is not possible. That's a possibility. Or another point is that we have been trying to find aliens just for last 40 years. Okay, on astronomical scale, 40 years is a negligible time. So maybe because of that, it's the fact that we haven't been listening long enough. So maybe if we try to find for a few thousands or tens of thousands of more years, there's a possibility that we might find someone out there. So that's another hypothesis. And then there are these laboratory and planetary hypotheses. These are the two more. Okay, so well, these are the ones which I was talking about. Like these are the ones which sound like they have been taken from these sci-fi movies itself. So I'll say these were variations of the zoo hypothesis. The zoo hypothesis that Konstantin Tsiolkovsky had put forward, which I mentioned earlier. Right. So what laboratory hypothesis says is that, as the name says, that humanity is a part of an experiment, and the laboratory is either Earth or our solar system. So, it says that it is possible that civilizations advanced enough to travel between solar systems could be actively visiting us, okay, or observing us. But they have such resources, or they have advanced such that uh, they are able to stay undetected, and like they are trying to experiment on us. That's one hypothesis. And the planetarium hypothesis says that so we are deliberately isolated by other species. Okay, so this hypothesis says that the Earth or the solar system is a simulation, or is a simulated reality. We are living in a simulation, and which is created by some other intelligent species or some other beings, and they have left us isolated deliberately. And it's again another variation of zoo and laboratory hypothesis, and they have left us isolated deliberately to uh, to see how we evolve. Okay, so both the laboratory planetary hypothesis lead to same fact that we have been left isolated deliberately, or we are avoided deliberately to see how we evolve. Okay, so well, and there are another one is that facts that like, the observation of UFOs. So some people think that although all the UFOs observed are not all the UFO observations are not real, some of them are fake, but some people think that some of them are real and that aliens are already here. They are wandering among us, yeah, as humans. So these are some of the hypotheses they have which are there. Okay, so there are a lots of and lots and other hypotheses are there. Like like a lot of scientists try to answer that like why the Fermi paradox is there, why we haven't had any evidence. A lot of scientists try to answer that, and well, there are lots of hypotheses which are there. Here I pointed just a few of them, which I thought to be interested, to be interesting. Okay, so whatever the fact is, whatever the hypothesis we go through, and whatever the equations or whatever paradoxes we talk about, the final question still remains: where are all the aliens? It, uh, in this huge, big world, in the universe of worlds, are we alone? That's the final question which still remains. And with that point, I'll stop here. Sorry that I it extended by 5 more minutes. It was supposed to end at 7:15. Really sorry for that. So I'll stop here, and if you guys have any questions, you can ask. Hello. Does anyone have any questions? Yeah, that might be another possibility. See, like we all the messages that have been sent, like, we have sent one message to the uh, Arecibo telescope, which is the radio band, and then we have sent a message, and then we have used the uh, uh, and then there are the physical messages like the one on Voyagers. But then, well, we have not used enough wavelength because we don't have enough technology for use them. I mean, this, the strength of radio wavelength is like they can reach longer, they can reach longer regions, right? So they can travel through mostly anything, but that's not the case with other wavebands. Like that's not the case with other types of lights, other uh, I'll say other wavelengths. So that's and we don't have enough technology so that we can use other wavelengths also to send some messages. So there is a possibility that the as I mentioned earlier that we have not been listening or listening properly. So again, it comes in that this is only we have not been listening properly. So we might need to use some other wavelength too, like for its purpose. Yeah, that's there. So like it's what we think. We think that only radio messages can travel huge distances, like galaxy distances. But well, that's how we imagine life forms to be. But, well, there might be possibility that it's not like how we imagine. It's something totally different. So well, I'm not totally sure about how to answer this. So, uh, well, based on how we have evolved, so first we are the organic life forms, right? And after this human named organic life form evolved, then after that we have started to uh, build the AIs and all, right? So, well, like uh, that's why I think that that's why we are looking for organic life forms. Like there is a possibility that, well, like the movies, which was it? I forgot the name of the movies. Yeah, it was a movie by Schwarzenegger, right? It was a movie series by Schwarzenegger. I don't know. I forgot the name of movie. Like like there the AIs or robots are trying to kill humans. That might be the possibility that the AIs, those organic life forms created, have killed humans and they kill life forms and they are there. That might be a possibility. Yeah. Or else there might be some other life forms also. But then I'm not exactly sure that why do we look for organic life forms? But then this is a water is okay. So Anirudh, all the questions you are asked are fair. But then I'm not exactly sure of how to answer these. I mean, well, these are fair questions. Like why we do this and why we do that, and why we don't do that. But well, like that's what we believe the life form to be. Okay, like that's how we imagine the life form to be. That's how we imagine the life form which is there to be. So because of that, maybe we imagine that the life form is organic. We imagine that the life form drinks water. We imagine that the life form exists in the habitable zone. And that's why we imagine that the life form exists in the habitable zone with planets which have water and it is organic. So that's that's the only answer I can think of right now. It's again our imagination. Yeah, yeah, yeah. Yeah, so if there are no questions, then we can stop here. Thanks a lot for joining in, guys. So stay tuned for next week. We'll have on the coming Sunday. Same another session of a part of the Paradoxes series. So stay tuned and have a lot of fun sky watching. But if the sky is clear, so yeah, thanks you for joining, and we'll stop here.